IEEE UCF's official podcast. We're your hosts. I'm Fernando.
And I'm Brian. On today's show, we have Alan Parker and Jonathan Lopez. Alan is an electrical engineer at NASA Armstrong Flight Research Center, AFRC. He is the lead for the FOSS team, which stands for Fiber Optic Sensing System. He graduated from Prairie View A&M University and then Texas A&M University.
And Jonathan is an aerospace engineer at NASA AFRC. He was a NASA NIFS intern for 2 rotations and a NASA Pathways intern for a year before being hired. DC graduated from California State University and was hired as a full-time this fall. Welcome to the show.
Glad to be here, guys. Thank you for the invitation.
Of course. Thank you for being here. So just right out the gate, oh, goodness. I do not have my pages in order. Look at that. Let's just talk about FOSS to begin. What steps brought you to utilizing a fiber optic reflection and refraction as a form of taking measurements?
Well, I guess I can take that. This is kind of strange because this was probably 25 years ago. Dr. Lance Richards and I were in the flight loads lab, and he and I both were talking about other means of doing structural health monitoring outside of using the more conventional measurement tools like the conventional strain gauge or thermocouples, instruments like that. And so we said, well, what if we can use fiber? We know that fiber is used as a measurement device. What if we can apply that for structural health monitoring on aircrafts? And so we started to kind of look around the industry, and we saw that sister facility, Langley of NASA, was actually starting to do some of that research. And so we partnered with them some 24 years ago on embarking into the area of using fiber as a means of making strain measurements and temperature measurements. And so one of the things that we brought to the table were our background in flight, with our ability to put things on aircraft and fly them and test them. So we had that capability, the ability to ruggedize avionics packages, to basically put things in flight. And so we took their base design at Langley, miniaturized it, enhanced it, added new algorithms to make them real time, and went and flew it. So, and we've been doing that development work ever since. So that's how we got started along the path of using fiber as a sensor.
Oh, wow, that's incredible.
And for the viewers out there that aren't really that informed, can you explain what FOSS is?
Repeat that question again.
Oh, for the viewers out there, I'm sorry. For the viewers out there, can you explain what FOSS is?
Jonathan, you want to take that question?
Yeah, I can take a stab at that. So FOSS, first of all, stands for Fiber Optic Sensing System. Essentially, what the technology is, you have a fiber, and within that fiber, you have what's called fiber Bragg gratings. Think of fiber Bragg gratings as your sensors. So within the fibers themselves, within the fiber itself, you have a fiber running along, and every so often you'll have that fiber Bragg grating, which are really just imperfections in the fiber. And you could have them at different long distances, right? 1/2 inch, 1/4 inch, or you could have a continuous fiber Bragg gratings throughout the fiber. And you could think of the actual technology as a strain gauge, right? The way the strain gauge work is you apply them to a surface, right? There's electrical resistance between the strain gauge, and as the panel or whatever you're applying the strain gauge on, as it expands or contracts, you get a difference in that resistance within the strain gauge. So that's essentially what the fiber optic is doing, except for now we're talking about wavelength, lasers, and light. So as I mentioned, you have your 2 fiber Bragg gratings. You apply them to a surface, and that's your 0. You know what the distance is between those fiber Bragg gratings. Say you put it on the airplane wing. As that wing starts to expand, those fiber Bragg gratings now get further away. and now that wavelength just increased in length, and we could calculate and correlate that change in wavelength to the stress that the panels the stress that the panel is actually witnessing.
Nice. So
So that's
something that
essentially what the technology is.
that's really cool, and something that that Alan had mentioned is it also has the ability to take in temperature readings. Is that different than the strain gauge relationship, or is it kind of a similar idea?
It's a similar idea, right? What happens to materials as they heat up or cool down? They expand and contract, right? So essentially, it's the same thing, but now the application of the optical fiber has to be different. We apply it to a surface. Like we normally do when we want to measure strain. If we want to measure temperature, we won't know what the difference between the stress is due to temperature or due to the actual physical changes in the panel. So we actually have to isolate that fiber in a little tube to make sure that the only change that we're getting is due to temperature. So as the fiber heats up, or when the atmosphere around the fiber heats up, that panel is going to increase in length, or when it cools down and gets cold, it's going to compress. Again, we could correlate that difference between those two fiber Bragg gradients and the wavelength between them and get temperature.
Wow.
Has there been like, when you first started this, both of you, was there like some sort of learning curve? I know for aerospace engineers, at least the majority in their undergrad or masters, they learn materials and those are subjects. But for electricals, we don't really touch on it as much. So was it difficult, or just pick it up easily as you went along?
Well, we could probably both answer that question. Jonathan from an aerospace engineering perspective and me from an electrical engineering perspective, but I can take a stab at it from a double E. Going into this research, this area of research, as most double E's and problem mechanical engineers as well are familiar with Fourier analysis or Fourier transforms. And for a double E, we use Fourier transforms to map time domain to frequency domain. And inversely, we use inverse Fourier transforms to map frequency to time. Well, when you're dealing with optics, especially when you're dealing with the methodology that we're using for our optics, which is called optical frequency domain reflectometry, we call it short for OFDR. We have not time and frequency, but we have wavelength and length domain. So when you're dealing with wavelength of light, in our application, when you do a Fourier transform on a wavelength varying signal, it transforms into the length domain or the physical length domain. And so making that mental leap between time and frequency to length, wavelength and length domain was a little stretch in the beginning. It was trying to wrap your mind around that. But once you did, it just becomes second nature to you. The original algorithms that were developed at Langley was based around the Fourier transform, fast Fourier transform, and we rethought that at Armstrong and used more of a short time Fourier transform. And so to be more efficient, a faster algorithm that could be implemented on DSP, CPUs, or FPGAs. And so that was one of the things that we brought to the table as a NASA center. So making that mental leap yet again in the fast Fourier transform domain, where you're mapping wavelength to length instead of time to frequency. And then of course, when you do short time Fourier transform, you add yet another dimension to that, right? You have time, you have position, and you have frequency. And so that was yet another thing that mental leap that we had to make. So Yeah, there you have it.
Yeah, I definitely can't talk to FFTs or anything like that. But as far as structural health monitoring goes, essentially what you're talking about is structures and material science, right? The way structures behave with different stresses and strains. I am an aerospace engineer, so I took some classes in structures and material science. I'm not a mechanical, so I didn't take the extra classes that they require the mechanical students, but I did get the basics, which kind of helped with this transition to kind of understand exactly how the technology is being applied, right? How materials act within a certain strain and stress level before the yield point, right? After it's linear before the yield point, and then once you hit that yield point, it gets pretty complicated, and you're talking about nonlinear and elastic behaviors. So I did have a little bit of schooling when it comes to material science, but not too much.
I think it's honestly amazing how much you guys both know. Like being an undergrad right now, I struggle with my classes, and it's not like as interesting because it's just from a textbook. So we don't see what's going on. We don't actually do, but just read the theory. And
yeah.
at what point do you feel like, I made it, or like I know you're just a higher last fall. Maybe you still like do that process. You don't know how to like process everything yet. But yeah, so how do you guys feel about it?
At one point, do you realize that you've made it?
Yeah, more or less. Like
Oh, I've been at NASA for 33 years, man, and I still haven't gotten to that point where I feel like I've made it, right? It's the day that you stop learning, Fernando, the day is the day that they put you 6 feet under. I feel like and I'm not going to speak for Jonathan, but I can definitely speak for myself. I'm always learning. I mean, even to this day, I'm learning new techniques, new software packages, new ways of doing analysis. Because things in technology, things are always changing. So you're always in a state of learning. You're always in a state of learning. And so I like to look at myself as practicing engineering, right? You're in school. You guys are in school right now. I'm still in school. It just takes on a different shape, but I'm in the state of learning, and I think I will always be in that state until the day that they put me under. So Jonathan may have a different concept on that, but
No, you hit the nail on the head there. I have to second everything you said, right? You're never out of school. You never stop learning, and I think that's the mentality you have to carry with you, not only in your career but in life, right? You can't stop learning. You can never get that satisfaction. Oh, I've made it. I can relax now. There's always like you mentioned. I'm a new hire, and I have Alan here who's been with NASA for 35 years. I will never be done until I at least have everything that's in his head right now. So I'm trying to learn as much as possible. And
but you can
there's
have that
multiple
next
people.
week.
That's not true. So yeah, so like I said, you have to be a student in life, right? Yeah, you're gonna be a student for the rest of your life, and when you have other senior engineers around you, the best thing you could do is just be a sponge and try to learn as much as possible from them. So you never actually make it.
That's so interesting. Maybe one day. I think that's so interesting though that we're always learning and we don't get bored. I guess in that sense, because there's always something new to discover and see.
Oh yeah, and after 35 years, that's quite some time. And keeping going seems to be the best bet. Do you see this project coming to a conclusion anytime soon? I know learning has to continue, but is this what are your thoughts on this project specifically?
Oh boy. Oh boy. I don't know if you guys are familiar with the Wheatstone Bridge Circuit. Are you familiar with the Wheatstone Bridge Circuit?
Vaguely.
The Wheatstone Bridge Circuit it's been a while. It's been around for a while, right? It's nothing new, but yet and still, there's still new developments, still new techniques that are based on that technology, and the inventor of that technology, long time ago passed away, and yet the technology continues on, and you can buy new products that has that technology in it. So the technology is not going anywhere anytime soon. And I see the fiber optic technology is as a not necessarily a replacement for the Wheatstone bridge, strain gauge, or thermocouple, because there's always going to be a need for those things. But it is a supplement to the engineer in terms of getting a new type of data, get a vast amount of data to try to characterize or model a system or a vehicle. But I do see my part in the process coming to a close at some point, right? I mean, I will push it as far as I can push it. And if NASA decides to move me on to a different project, or I decide to retire within the next couple of years, I will cease working on the technology, but the technology will continue on. I mean, you got young guys like Jonathan here on the call that we've brought into our group, guys like Dr. Patrick Chan, we have Paul Bean, we have Frank Pena, Eric Miller, the list goes on. And these are all relatively young guys. We're constantly bringing in students seems like every term. Students like Juan and Jackson and Daniel, who are currently our students. Those are the ones that will carry on the technology. My window of opportunity will come to a close one day, but theirs are just opening up, right? And so I may not be the one that see the FOSS system version 10, because I've only taken it to version 5, but someone like a Jonathan will probably see version 10, or Juan may see version 12 or something like that, and I'll be up in heaven somewhere watching down on you. But yeah, I don't see it going anywhere. It will continue on. It's going to change. It's going to change hands. There's going to be a different champion for the technology. So, yeah.
It's awesome. It sounds like you're really proud of the system. Where do you see it going beyond the space industry? Or where would you like to see it go beyond the space industry?
Oh boy, where wouldn't I like to see it go, right? Well, the technology is commercially available in industry right now. So we have industry partners that have come into NASA and licensed the technology, and they are selling this NASA technology as a system in multiple markets, right? Multiple industries, all the way from the oil and gas industry to the medical industry, automotive industry, wind energy industry, aeronautics, as well as space, right? So it's across the board. To be quite honest with you, I am proud of the technology, right? It's really cool, and it does a bunch of good stuff, and but I can tell you what I'm most proud about, and what I value more than probably the technology itself, is the opportunities that it gives us to work with students, right? I mean, because to be quite honest with you, they're the ones that are the future, right? It's not me. I've hit my peak. I'm on
still
the
have
other
time
side.
left.
I'm on the other side, right? But for me to be able to use a platform like the FOSS to invest in people like Jonathan and Juan and Jackson and Daniel and some of our previous students. I mean, I've had, over my career, I've probably mentored 250 students.
Wow.
Over my career, and it is those that I would say I'm most proud of, because when I'm done, they will continue to work. whether it's working in FOSS or whether it's working somewhere else, working for a different company or NASA, it doesn't matter, but they will continue to work. And matter of fact, I just got an email from a student this morning. He's working at another NASA center, and he was just sending me an email because he recalled the time that he spent with us in the lab as one of our students, and how much he valued that and how that changed the way he viewed engineering. Man, that meant the world to me to get an email like that. So, yeah.
Well,
Did that answer the question, or did I just ramble on?
I mean, I think it answered the question. I think that's incredible. I mean, just hearing this, it's sometimes, you know, in academia, you'll run across individual professors that you know are there just for the research, and they make it obvious. It's no secret to the class.
Yeah.
So hearing someone, you know, as successful and as that has such an impact that you have, showing these true colors of how much you really care. I mean, it's really refreshing, frankly. It's really wonderful to hear that. So I think you answered the question and more.
Okay. All right, good. I don't want to leave you hanging on that one.
It's all good.
No, but I also completely agree. It's really amazing to see someone passionate and try to get back and like shape the future, you know? With that being said, when you were both younger, was there anyone like shaped your future that made you go to where you are today? Something that inspired you, a book, a person?
I know for me, but I'm going to let Jonathan answer it.
What really got me into engineering was two things. First, it was growing up. I grew up maybe a mile out of LAX, and you know, living a mile out of LAX, you got these big airplanes, 747s, Boeings are taking off and landing, and they're probably 100 feet above the house, and they just shake the whole house, right? It's just that power of those airplanes and just the size and mass of them that just always intrigued me. Like, how can it get something so heavy, so big, to actually fly and maneuver like that? When I moved out to Lancaster, I started seeing fighter jets out here. So F-22s, F-35s, the B-2s, and that really got me going even more, right? Then in high school, I took an astronomy class that really just talked about space and exploration, and that really started to kind of open my mind to the possibilities out there. So I knew I wanted to do something engineering, but after those two things, I knew I had to be either in aeronautics or astronautics. And being at NASA Armstrong, I get the best of both worlds. It's an aeronautical center, but as you can see, we work on space projects as well. So that's what kind of got me to where I'm at today, I think.
Yeah, I tried to convert him over to double E, but that didn't quite work. So
Never too late.
I think Alan tries to convert every student we have come into the lab to electrical.
yeah, I try, but it doesn't always work. I've been successful a couple of times in the past, but not that often.
It's a good field.
I agree completely.
Although I will say, no offense, Jonathan, I do have a bias being an EE. I mean,
yeah, I think there's a room full of double E's. So.
But Alan, what about yourself? Do you have any like story about your come up and someone that inspired you or something?
Oh man. As a kid, I was always intrigued on how things worked.
Mm-hmm.
I remember one year I was given a little arcade game, little handheld arcade game. Very elementary compared to what you guys know of as games today. Just little lights on the screen, right? Just a couple of lights, you know, football game and a basketball game where you just maneuver around. And I remember getting that for Christmas one year as a kid and thought, man, this is amazing. I mean, you hit a button and you can actually control what goes on. Oh, I thought it was amazing. And I would take those things apart to look inside to figure out how they got that stuff in there, right? I would take it apart and I could never get them back together again. And I didn't understand what they were. So as a kid, I just started looking We didn't have the internet at the time, but we had dial-up bulletin boards, electronic magazines, and things like that. And so I was hungry for it, and I just dived into it, and I started studying circuits. I was probably 11 years old when I started studying circuits. Radio Shack was big at the time, so I was constantly going to Radio Shack, getting those little radio kits that you wire up and build your own little radio or transistor amplifier radio and whatever. And then my mom would always tell people, my son is going to be a NASA engineer one day. And of course, being a black kid from the hood, that was an impossibility, because when you looked at NASA on TV, all you saw were guys that didn't look like me, right? So I just thought that it was an impossibility until one day my dad somehow got me a tour at NASA Johnson. And this was when Charlie Bolden had just arrived at Johnson, I believe coming either from the Marine Corps or the Navy. He was a pilot. And he just arrived in the astronaut program. He was the first black astronaut. And he got stuck giving me the tour because he was the new kid on the block. He was the young guy. So yeah, you give that snotty-nosed kid the tour. And so I remember, I spent maybe an hour with him. And I remember walking away from that exchange. I was 12 at the time. And I thought, if he can do it, I can do it too. And so that's when I set my goals when I was 12. My mom said I'm going to be a NASA engineer. I think I can do it. I see Charlie Bolden doing it. And so I'm going to set that as my goal. And so I did. And so here we are today.
Wow.
I had an opportunity to run into Charlie Bolden a few years ago when he became the NASA administrator. He came out to Armstrong right after he took that position. And I remember going up to him, shaking his hand. I said, "You're the reason why I'm here today. I met you when I was a little kid, and you're the one that influenced me that convinced me to become a NASA engineer." So I stand on his shoulder.
That's magnificent. Oh my goodness.
It's so powerful.
Wow. And now you're here and you could be an inspiration to so many more people coming up. That's astounding.
That's why I feel, if you have an opportunity to invest in someone, even if it's just an hour, if you have an opportunity to invest in someone, you never know what's going to come about of it, right? And you just, I'm just going to invest. I'm going to spend this time with that person, and hope that it will turn out to be fruitful in some way, shape, or form, right? But sometimes it is, and sometimes it isn't. But oh well. I like to think that I can do my part and invest in the lives and opportunities that I have to invest in. So, like Jonathan, yeah.
So on your journey to, from being a kid to being a kid to an engineer, being a minority as well, being a person of color, I faced racism myself. I was born in Lima, Peru. But on your journey, have you guys faced something that just made you stronger, changed your point of view, or just shaped you to be you today? And how's the industry changed actually for the past 30 years? I think that's more interesting too.
Jonathan?
Well, he asked how it changed the last 30 years. I think that one's for you.
Little sprinkle.
Well, that's a good question. In the perfect world, right? Race, color would not matter. But we all know that we don't live in a perfect world, and we are not perfect people. And so we grow up with different prejudices, whether good or bad, we do. I don't care what color you are. We all have some form of prejudice, and unfortunately it works in just about every aspect of life, whether you're at work or you're at home or in your community, wherever you find yourself. And I would say that Armstrong is, and I've only worked at Armstrong in my professional. I used to work at Motorola, but that was as a student prior to coming to Armstrong. But Armstrong does a really good job of being as fair and equitable as possible. But we deal with everybody has their prejudice. So no matter where you're going to go, you're going to find some elements of that. But the important thing is to make sure that you are aware of your downfalls and do your best to avoid that from coming out in the workplace, in your relationships, in your community, and do your best to suppress those downfalls. Sometimes we're successful and sometimes we're not. I've been at Armstrong for 33 years. Is there another place that I would rather work? No, it's not. Have I been fortunate to work with good people? Yes, I have. Have I run into racism at Armstrong? Yes, I have. But I would say that I would run into that anywhere I went. I came to California, coming out of Texas, thinking that I would not see racism here, but racism is here just like it is in Texas. You know, you go somewhere north and you think, well, you're not going to find racism out there, but yes, you will. I don't care where you're going to go. We all have prejudices, you know, and it, unfortunately, it shows up in the nastiest of ways sometimes. But we just got to do our best to treat everyone fairly and equal and love our neighbors, as the Bible says. So.
Yeah, the only thing I will kind of add on to what Alan is saying is just you can't let that stuff get to you. You just let it build you up, right? Let it build up your skin, have tougher skin, be better than that person. Don't stoop down to their level, and just let it build you up, and just work harder and prove them wrong. It usually works out in your favor anyway. If you work even harder just to prove them wrong, whether you agree with that mentality or not, at the end of the day, you come out on top because that's what gave you the extra push to keep moving forward. So let it build you up.
Yeah, I remember growing up, my dad instilled in me, because I was a man of color, a young man of color, and growing up in the 60s, I was born in the 60s, and my dad saw a lot of racism, and he, as a matter of fact, he was a civil rights leader back in the day, and he would always tell me, he said, son, you have got to work twice as hard. Simply for the simple fact that you're a person of color. You have to work twice as hard. And I found that to be true. I found that to be true. You know, Jonathan and I have kind of a unique relationship, I think, because you know, I'm engaged with interviewing all of the students that I bring on into our group, into our FOSS group. You know, I get them on the phone, I talk to them, I ask them questions, things like that. And I was going through my roster of students, and I usually will have maybe 100 students apply for our position, and we may pick 5 or 6 or 8 students. And so, you know, we go through the weeding out process, and I had already picked my students for this term, but there was something about Jonathan that stood out, right? Just his choice of schooling, He started out at a community college. He transferred from a community college to a four-year university, and so that just, for some reason, that intrigued me. His resume intrigued me. But I already had my students picked out, and I had my funding for X number of students, and I already had them picked out. But I wanted to talk to this young man on the telephone, and I remember calling him, and he took my call, and I said, the first thing I told Jonathan, I said, Jonathan, I just want you to know that I already got my students.
Yeah.
This is not an interview. Don't think you're gonna get a job. I said, so you can choose to talk to me further or not. And Jonathan gracefully endured the next, I guess we talked for maybe 40 minutes.
Yeah, it was a long conversation.
It was a long conversation. And I just pinged him on his choice, why he did what he did, how is it working out for him, and so on and so forth. And at the end of the conversation, I said, you know what? I don't care if I have all my students. We need to make one more slot for this for this kid. And so I went back to the student coordinator. I said, look, I know I got all my students. I don't have any more funding, but we got to bring this young man on. We got to bring him on. And so we were able to create a slot. We invited him out, and the rest is history. Now he's a permanent employee of Armstrong. But anyway, I digress. So
yeah, I will say there's a bunch of stories like that throughout my path to where I'm at today. So that's the first story. Then just transitioning to pathways and getting a full-time job. There's just stories like that. But yeah, to build off of what Adam was saying, when you get an opportunity like that, all I asked for was an opportunity. I didn't ask for anything else, just an opportunity. I must have filled out over 100 applications for internships over the span of a year. I only got one call back, one,
Wow.
and it was from Mr. Alan Parker. That's the only call. So when he called,
well,
I
I'm glad I was the only one you got.
he was the only one that called. So all I wanted was the opportunity. When he gave me the opportunity, I only have one task at mind, one objective in mind. Even to this day, is to prove him right. He made a decision. He made a choice. Let's give this guy a shot. And to the day he retires, or even after he retires, my only job is to make sure I prove him right, that he made the right decision.
That's so cool. And as somebody who went to community college, I'm actually in the process right now looking for a new job, and I've always had this debate in my head, like, do I keep that on my resume? Do I take it off my resume? Do I keep it on my resume? Is it that important? But hearing this story right now makes me feel better about the fact that I have kept it, because I don't want to just pretend like I jumped into UCF at the time I did and just ignored what my history is. Jeez, let me stop hitting this mic.
I'm curious about your resume now. But with that topic though, do you have any advice for like students? Something you will put in your resume, take off your resume, something that just stands out. Like what did Jonathan have that you were like, ooh, I want him, basically?
Jonathan it was a combination of things on his resume that stood out. That he went to a small town, small community college, and he transferred to a relatively large school, and he still maintained a GPA that was stellar, right? It's not easy going from a small community college to a major university and still keep the same pace, still keep the same performance in your grades. I mean, that's not an easy task. When I look at resumes, keep in mind that the resumes that I come across, they are most of them have good grades. GPAs, I usually have a cutoff of about 3.6, somewhere up in there, 3.5, 3.6 ish. NASA has, I think, 3.0 or something like that. But if I'd have hundreds of resumes, right? I have to have some means of whittling it down. And so I kind of start with looking at GPAs of about 3.5 plus. But even then, you have a bunch of students, right? So one of the things that I look for is, all right, a lot of people can go to class, can study, do well on a test. That's great. But how does that translate into real life for you? Is it all about books, or do I see something on your resume where you're working on a research topic with a group of students that are building this, or you're building that, or you're getting hands-on experience here, or you know what? I worked full time while I was going to school and I still made a 3.8 GPA. And I'm thinking, and I see stuff like that. I'm thinking, man, that kid is multi-dimensional. He or she can handle stress. They can perform. They're just not all about, they're more this than they are this. And I want healthy, mentally healthy people that that will perform, that are smart, that has a diverse background, that can think outside of the box, that's creative, that's not afraid to take chances. So if I can see that, if that can be conveyed to me in the resume, that's what I look for. It's the grades that gets me to look, right? Because I have to use some way of whittling down all of those resumes. But once I get past the grades, then it's like, okay, what type of person is this?
Very nice. Sounds like you've had a very busy life for the extent of your entire life. Obviously, we've done some research before coming in contact with you, and it seems that, although you've been labeled certain things like a super genius, et cetera, with your incredible products you have worked on and created, you also seem to be very focused on the fact that you're human and the fact that you've lived your life recognizing your humanity. How do you balance, in a sense, like the work-life balance, the family life balance? How do you feel you've done with that, and how do you reflect on that looking back?
Well, I can't say that I've always been this way, because I have a wife that helps keep me in line. I remember when I was Jonathan's age, when I was your guys' age, all I wanted to do was create. I wanted to be in the lab. I wanted to be building things, and that's all I wanted to do. I mean, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and that was my life. And so I was very out of balance. And I gotten married to this wonderful young lady, and she said, nope, all that's going to come to an end. You cutting that stuff off. You work Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. It's mine. But yeah, she helped bring balance in my life. And I think we all have to be able to do that to stay healthy. I think that we're seeing it more and more as we go through this COVID-19 2020 year that we've had, where we see the value in relationships, right? We see the value in having community with people, having fellowship with people, and that is a major part of life. And when we start to short circuit that, then we get out of balance and we become unhealthy. So, for me, God comes first, family comes second, the work comes third, and everything else comes after that. And I just gotta keep that balance. So.
That's really awesome. And then obviously from you talking about, looking at resumes, Jonathan, you've evidently been doing well in school, living your life. Do you feel your work-life balance has been maintained at your age currently, or what are your thoughts?
Yeah, I think it's gotten a little better at least now since I'm not in school. The whole time I was working at NASA as an intern, I was also doing school at the same time, so I did both. And I live up in Lancaster, and I drove down to Long Beach, which is usually on a good day a 2.5, 3 hour drive.
God.
With LA traffic, it could be more than that. But long story short, yeah, at that time in my life, it was school, work, school, work, school, work, drive, school, work, drive, school, work, drive. So the good thing now is I still have that. I'm so used to occupying my time with school or work. So when I'm not working now, when I'm not working on a specific task, a work task, I'm usually trying to learn a new skill or task, like Alan mentioned. So I'm still at that age, still at that point. I'm early in my career, so I just want to I just want to start off on a good pace here. And as an aerospace engineer, you can't. The one thing, at least in my mentality is you can't be a one-trick pony, right? If you're an aerospace engineer, you can't just have tunnel vision. I'm only going to do aerospace tasks and aerospace learning. Throughout my time at NASA, like I said, I try to pick Alan's brain as much as possible when it comes to electronics, software, other people on the team. We have Patrick Chan, who's a wizard when it comes to optics. I try to pick his brain. So the main point I'm trying to get across is you can't be a one trick. Have some spare time. I would, at least for me, I would say definitely try to learn new tasks and new skills that you think will help you in your career and that you enjoy. Right? If you have passion in it, it won't feel like work. It won't feel like an obligation. It'll be fun to do.
Yeah, I recall those days, Jonathan, where he was working at during the day at NASA, then in the afternoon he would drive down to Long Beach. And I would tell him, I said, Jonathan, you can, instead of driving all the way to Edwards Air Force Base, which is opposite direction of where Long Beach is, right? It's like, instead of doing that, why don't you just work from home a few days a week, and from there just drive to Long Beach? Nope, I got to be in the lab. I got to be in the lab. So he would get up. It must have been 5 o'clock in the morning because he was there at Armstrong at like 6 or 6:30. He worked till about 11 or 12 o'clock, and then he would drive for 2 hours down to Long Beach and be down there for until like 8 o'clock at night, doing classes and meeting in groups, study groups and things like that. Then he turns around, drive home, do homework, get up the next morning and do the same thing over. I said, this kid must be crazy. He's lost his mind.
Yeah, it all comes back down to I had that mentality that, all I wanted was opportunity. So when you get the opportunity of a lifetime, you have to take advantage of it within the lifetime of the opportunity, right? It could have came and passed. So whenever I got the opportunity and to extend my internship, I said, "Yep, I got to go back to school, but that's fine. I'll do both at the same time. It's okay."
Wow, that
Oh,
sounds
yeah.
honestly really stressful. Even with like my classes, I'm like stressing. But so how do you deal with that? Honestly, any like tips, any advice?
Just go through it. I know it's pretty cliche, but it's just hard work. It's a work ethic. You have to have a strong work ethic, right? And to be honest, when it comes to university, a lot of your assignments aren't due the next day or the next 2 days. You usually have that weekend to do your work. So that's usually what I did. Friday, Saturday, Sunday, didn't do much except homework and study for my test.
Wow.
I always had a vision. I always knew what was the end goal. So I stayed focused and I knew what I was doing was for a reason. So yeah, it was tough going to school, being at NASA at 6 in the morning, working 6 hours, driving 3 hours, doing school for 5 hours, and driving 3 hours back home. But I always knew there was an end goal, and I had that vision. So just remind yourself why you're doing what you're doing. Why are you going to school? I'm sure no one's forcing you guys to go to school and do what you're doing. So keep that in the back of your head whenever you kind of feel stressed or you have a lot of pressure on you. Just remember why you're doing what you're doing.
I find that really interesting because you said, yeah, homework extended the next day, which is a good thing and a bad thing. Because then you get into the mentality that, oh, I have more time, I'll do it later, you know? And then it's just a cycle that just ruins my life personally. But I'll try to change my mentality. That's really interesting.
And obviously, like you mentioned, passion is also a big part of it. Do you, just for the viewers out there, does the passion get rid of the stress?
I think it could help you with the stress, but it all comes down to how you deal with that stress or how you perceive the stress, right? Stress could always be it could be a bad thing or it could be a good thing. Stress can push you to do things that you didn't think were possible, right? If you have stress and pressure on you, you will perform differently and you will do things that you didn't think were possible. So, you know.
Well, I always say this. I tell my daughters, and I've told all of my students this as well, that in life, it is what you make it, right? It is what you make it. And if you find out early on how you have been gifted in terms of where your talents lie, the things that really turn you on, the things that get you excited, right? Things that you don't mind doing. I said, I tell them, if you can make a living doing those things, then you'll never work a day in your life. If you can make a living doing the things that you love, you will never work a day in your life. And what I mean by that is, if you get up on Monday morning and you're excited because you're going to work, because you're going to do something that you love, it's really not work for you, right? It really isn't. And Friday comes around and you're bummed out because, man, I got to wait till Monday before I'm back here again to do more of this good stuff, right? So, if you can find something that you're passionate about that really gets you going and it can pay your bills, then, man, do that. And then your stress level, the stress level that Jonathan was talking, that you guys were talking about, yeah, you have moments of stress, but you'll be stressed doing the things that you are passionate about doing. You're not stressed about, man, I don't want to do that because I hate my job. Monday is wrong. Oh, I hate Mondays. I love Mondays. I do. As long as I've been at Armstrong, I love Mondays because I have the opportunity to go to work because I love what I do.
That is so cool. That's absolutely wonderful and such great advice as well to those who are listening. And I'm obviously myself as well. Thank you.
I'm absorbing everything right now.
But I think we're starting to get to that time where we're going to be closing this podcast down. Do you guys have anything you'd like to say? Some last minute advice, last minute comments, shout yourself out, etc.
Oh, actually, before that, we do have a couple questions from the audience, I guess.
Yeah.
So we'll just go through that real quick. And to both of you, so have you guys ever thought about becoming an astronaut? From Linda A.
Nope. No, I never wanted to be a pilot. Never wanted to be an astronaut. That part didn't fascinate me. It was the electronics that fascinated me that were on the airplanes and on the rocket ships, right? That's what fascinated me. The guy behind us that's working the stick, nope, have no desire to be that person. I have no desire to go to the moon. I have no desire to go to Mars, but I love to design the equipment that will get you there. That turns me on. Everybody's different, right? Everybody's different.
It sounds like you're in the right place.
Yep.
And yourself, Jonathan?
Yeah, I definitely wouldn't mind being an astronaut. That's for sure. I'll
Like I
definitely.
said, everybody's different.
I'll definitely put in the applications. And if they call, they call. They don't, they don't. They recently did increase the requirements that you now have to have your master's. So I have to at least go back and get my master's. So, but yeah, like I said, it doesn't hurt to fill out an application. But in the meanwhile, I mean, if I can help people get there safely, do their job easier, or help in the Artemis program as much as possible, then I'm fine with that as well.
All right. We have another question from Jordan Schneider, actually our technical director. He asked, "What is the work dynamic at NASA? Is it a lot of teamwork or a lot of independent projects that get put together in the end?"
I'll start this one off. Yeah, I mean, the atmosphere at Armstrong is awesome. I will say, Armstrong, at least I could just talk as a center because I haven't worked at other centers, but for sure for Armstrong, it is a big, it feels like a big family environment, right? It's a good atmosphere. Everyone's willing to help you and talk to you. You could stop anyone who's walking to a meeting and ask them questions, and they'll help you out with whatever you need. As far as work goes, yeah, definitely everything you do around NASA is all team atmosphere, it's a team environment. Everyone's working to a common goal, a common task, and you have different people with different skills and different expertise that all come together and try to get the task done together. There is no individuals that come together at the end. Oh, this is what I did. This is what I did. It's definitely a team environment.
I think that's interesting, actually, that you say that, because that's the one thing we don't really learn in college, to work in a team. It's usually by yourself. And lab reports, it's a lab, but like you're not really working together. You're trying to get it done. And we have our last question from Andrew O'Reilly. You always want to work in the space industry? If no, what industry do you want to work for?
I mean, to build off of one of my previous answers, yeah, I always had the space industry in mind, and also the aeronautics industry. As long as it was in the aerospace industry, I was happy. Like I said, working at Armstrong, you get the best of both worlds. So you get some aeronautics and astronautics. So definitely happy where I'm at.
I would say I knew that as a young man, as I mentioned earlier, that my mom put the thought in my head. She's the one that seeded the thought, right? And I don't know if you guys got kids, Jonathan, you don't, but I don't know if you guys got kids, but you have opportunity to build into your little ones, right? And you can actually see thoughts, because as a young person, we're just out doing what we do as a young person. But your parents, they're watching you, right? They know what type of person you are. They know the things that you like. They probably know you better than you know yourself when you were a little kid. And so my mom knew that about me. She would watch me and watch what I do and what made me happy and things like that. And she just seeded that thought in my mind that I could be a NASA engineer, right? And so that was the one thing that sparked in my head. I wanted to be a NASA engineer. I mean, there was no cooler place to work than NASA, because they were on the cutting edge of everything. And so knew I wanted to work for NASA. And so when I was in college, I had an opportunity to interview with another guy by the name of Charlie. His name was Charlie Brown. And I interviewed with him, and he picked me as an intern, and I've been out there ever since. But yeah, even as a kid, the thought was put in my head, and I agreed with the thought that, yea, verily, I wanted to work in this industry. Not because I wanted to be an astronaut or a pilot, but because it was just cool technology, and I love technology. I wanted to be on the cutting edge of whatever it was.
And that wraps up our questions. So, quick thank you to the audience for sending them. And it's that time to wrap up the show. So, is there like anything you want to shout out? If you last minute advice, something you want to tell people?
Don't give up on your dreams. Like I just want to reiterate what I said earlier. Find out what makes you tick and pursue that. Try to make a living from it. You don't want to hurt anybody in the process of doing that. You always want to, whatever that thing is, you want it to be something that adds to society, that adds to humanity, and you enjoy doing it, and it will sustain you in life. And pursue that. Keep priorities your priorities, and stand by your beliefs.
Yeah, the one thing I will say, just to reiterate what I said before about opportunities, is take advantage of every opportunity you have. And when you, as a student, when you do get an opportunity, or after you graduate, when you do get an opportunity, treat that opportunity as if it's the last opportunity you're ever going to get for the rest of your life. Have that mentality and don't let it go. Yeah, you might get other opportunities later in life, but just have that mentality that this is your only opportunity. I got to do what I got to do to make sure I grab hold of this opportunity and take advantage of it.
Well, I thank you guys for inviting us. This has been great. We don't have an opportunity that often to converse like this. This has been really cool. I hope we have an opportunity in the future to come back and do it again. So thank you guys, Brian and Fernando and Juan, for your patience and your questions and just entertaining us. So this was great.
Thank you for your time. It seriously has been. I've thoroughly enjoyed every second of this.
All right, guys.